We've always used this as a square root sign. That's why we've always called it a square root sign. But now we are older and more mature mathematicians, right? So we're going to do it to, we're going to use it to do a cube root, or a fourth root, or a 12th root, but we don't want to do 12th roots. But we could. We could. Okay? So here's the thing that I may or may not want to show you, but I'm going to show it to you anyways. On your calculator, let me zoom in a little bit. Nope, wrong way. Zoom in. See the yellow part right there? On the caret button, the up arrow button, it says n and then it has a root with an x inside. If I press control and then that number, it's asking me for what root am I taking. Your calculator doesn't even automatically assume you're taking the square root anymore. There is a dedicated square root, but there's also this one over here that's an nth root. Okay? So we could take the fourth root of 81 and know right away that it's 3. Okay? Now, we know that from this chart, zoom out, because our fourth root of 81 is 3. But sometimes we'll have the chart, sometimes we'll have the calculator, sometimes we'll have both, sometimes we'll have neither. And we got to kind of be familiar with some numbers, right? Okay, so we talked about taking the square root of a number, simplifying the radical, right? We talked about actions that we're allowed to do with radicals. Is multiplication the only one we're allowed to do? Are we allowed to do this? The cube root of 7 plus the cube root of 7. Am I allowed to do that? I am. What's the answer? 2 cube roots of 7. Why didn't I just add the 7s? That's only when we're multiplying. Okay? We can only pull numbers inside the radical when we're multiplying, not when we're adding. Okay? But are we allowed to do something like this? The cube root of 24 over the cube root of 8.
Yes.
Yes, we are. Okay? If we have the cube root of 24 over the cube root of 8, what are we allowed to do?
24 divided by 8.
Do we know 24 divided by 8? 3. So the cube root of 3. Do we know the cube root of 3? No. So we're done. That's the answer. Any questions about any of that? There was one problem on your homework from last night that was particularly ugly. Okay? So I want to make sure that you're okay with it before we try to go on to stuff today. Because if you're not okay with it, today's stuff may or may not make any sense to you. This was the problem from the homework. Am I allowed to multiply unlike bases and mess with the exponents? I can't, can I? All the stuff that we learned on the foldable yesterday, the product of powers and everything like that, really depended on if the bases were the same. If the bases are the same, then I can add the exponents. Are these bases the same? So can I add the exponents? No. But am I allowed to make the bases the same? I can, can't I? Okay? So what if I rewrote this as 2 to the 3rd, because that's what it is. But what if I rewrote 16 as something different? What base do I need? I need a 2, don't I? Isn't 16 2 to some power? What is it? 2 to the 4th, right? What about 4? Isn't that 2 squared? To the 2/3 power? Do I know how to mess with stuff like this? Oh look, power of powers. Huh. This is really 2 to the 2/3 power times 2 to the 8/3 power over 2 to the 4/3 power, right? Now are all the bases alike? Yes, now I can start doing stuff, can't I? Well, what do I do with the numerator? 2 to the 2/3 times 2 to the 8/3. What does that end up being?
4 to the 7.
10, 2 to the 10, I don't know why I wrote 4. 10/3? If I'm multiplying like bases, don't I add the exponents? When I'm adding fractions, I add the numerator and leave the denominator, right? Over 2 to the 4/3. If I'm dividing like bases, what can I do with the exponents?
Wait, why is it 2 to the 10/3?
Because it's all my bases.
So you're not multiplying 2 times.
Look at my product of powers rule. I just leave the base the same and add the exponents. I don't mess with the base. This doesn't say a to the m times a to the n equals b to the n plus n.
I thought when you said that you were talking about the base.
Nope, we got to keep the base of the exponent the same.
Okay.
Does that help?
Yeah.
Okay. So that stays a 2, and I just add the exponents. Okay? Yeah, when it's a variable, it's a lot easier to talk about because variables aren't, I mean, by definition, variables change, but in that case, the variable stays an x, right? When it's a 2, you got to do the same thing. You got to leave the base alone. Okay? What can I do with the exponents now? Subtract. Right? If I'm dividing like bases, what do I do with the exponents? Subtract. So 2 to the 6 over 3. Do you guys know what 6 over 3 is? So 2 squared, which is 4. So after all this mess, my answer is just 4? Oh my gosh. How irritating. Okay, does that make sense? This is how we need to be able to manipulate our exponents. We need to realize we need like bases. The best base to choose here is 2. Why didn't I choose the base to be 4? Because isn't 16 4 squared? Isn't it 4 already there? Can I make 2 become a 4 somehow? I can't, can I? Okay. Well, I mean, I can, but I don't want to go there right now. Are you okay with that? Okay. Questions?
On the remember we did like a 3 cubed of 7 plus that 3 cubed of 7?
Right here? Uh-huh.
Yes.
This is adding. So if I'm adding, this is what you do.
And then we got like 24 over 8. What else we got?
This was another example.
Oh,
So this was a sample example. This was a sample example.
okay. Oh, I just read it wrong. Sorry.
Okay, you're fine. Any questions?
Like, you know the cube root of 2. Why did we put 2?
If I what?
Like, you know the cube root of 8 is 2, right?
I do know the cube root of 8, right? But what I recognize right here is that I don't know the cube root of 24. So I want to pull all of this into one common like root so that I can actually divide right here. Because if I just did that, I would get the cube root of 24 over 2, and that's not completely simplified. Because I still have a cube root right here, and I still have numbers I can pull out of a cube root. Because this, if I was asking for the cube root of 24, well, I know 8 is divisible into that, right? So I'd have to do the cube root of 8 times 3, which would be the cube root of 8 times the cube root of 3. And I know the cube root of 8 is 2, so I'd get 2 cube root of 3, but I still had that denominator of 2, so I'd have to simplify common factors, and so I would just get 3, or the cube root of 3. So I still get to the same answer, it's just a whole lot less steps. Okay, so yeah, you can absolutely do it that way, it's just not the fastest way. Okay? Questions? You think you can understand all these different things that we talked about? I know it's a lot of different things in one lesson, but these are kind of like different, small different things that we're going to have to be able to do. And none of them are really one lesson. You know what I'm saying? They're not long enough for one lesson, so I just kind of put them all together. You okay with that? Great.